Okay, so this video is going to be about Precision Boost Overdrive 2 and specifically for the Ryzen 5000 processors, the curve optimizer. I feel like there's a lot of confusion out there right now on what settings to use, what the settings do, what order to go about setting the settings, which ones are a priority, how they interact with each other. So I'm going to try to answer some of those questions. And I'm going to go over maybe a set of test tools right now that you could download. So let's just get started. Useful tools here. Ryzen Master. Very useful for verifying the settings that you set in your BIOS, right? Your power limits I like to use these for, and SoC voltages if you do Infinity Fabric stuff, which we're not covering Infinity Fabric here, but it's good for verifying. You can also see how much of your power limits are being used, but I like to use the next one for that. Anyhow, Hardware Info 64, the best monitoring software out there. Don't use something else, in my opinion. Just use Hardware Info 64 for monitoring. You can also use CPU-Z. CPU-Z is good at just doing quick checks of things on your CPU, like what's your memory frequency running at? Is it? You can do a info printout, which I find very useful for CPU-Z. It has a little benchmark as well, a little stress test. So that's a useful tool. I've been using that for years. Notepad++. This is just a better notepad. It's great for taking notes, right? You make some settings, you run Cinebench 23, you write down your score, etc. ADC 64 is just a huge test suite. I actually mainly use it for memory testing, but I have a license to it. It's a good program. OCCT, fantastic stress test tool. I think it's made by one person. You get an hour of stress testing for free, and if you buy, you'll get unlimited stress testing. Prime 95 is a classic stress tester. Run like smallest FFTs to hit your max temps, and just stress test the highest multi-core load you can. Cinebench 23 is very good for performance rating. You can use it as an extremely coarse stress test. Like if you're very unstable, Cinebench 23 will probably crash. It's not a serious stress test, but if you crash on Cinebench 23, you're very unstable. But I use this mainly for comparing performance between settings, right? So I change a power setting and I run Cinebench a couple times and get the average, write it down. Change the power setting again, rinse and repeat, okay? Handbrake, it's just a FFmpeg with a GUI on top, I believe. It's great for doing like a long real world stress test. So I like to do an H.265, which I think uses AVX instructions, gets nice and warm. It runs, for a long time generally. H.265 at 4K is a pretty slow transcode. And then some game benchmarks, right? Like Shadow the Tomb Raider. Shadow the Tomb Raider is a great game benchmark, I think, because it's free on Steam if you get the demo, and it scales really well with CPUs. Okay, next. All right, so what is Precision Boost Overdrive 2? It's AMD allowing you to customize the boost algorithm for your CPU. Each CPU will have different limits that it can hit, right? Some will want more or less power. Some will be able to boost higher. Some will be able to run at lower voltages, etc. So there's four main parts here: the power limits, the curve optimizer, the boost override or auto OC, and the scaler. Okay, so the power limits consist of three limits: EDC, electrical design current, which is the peak current that your VRMs can support or will supply during transient conditions. This means like when it's increasing boost, right? When it's pushing the boost levels. This is what we're going to use to really tune the multi-core boost of the CPU, okay? The boost algorithm tries to keep the EDC at whatever you set it at, right? You set it real high, it will hit that EDC. Set it real low, it'll constrain it to that. The TDC is the thermal design current. This is the amount of current your VRMs will supply during thermally constrained loads like long renders, when the boost is kind of static, all right? This is generally lower than the EDC, and it doesn't, it's more of a, whatever the TDC is mostly determined by how much the EDC is set to, okay? So for instance, if I set my 5950X EDC to 220, the TDC it only hits as like 162, all right? So if I set TDC to 200 there, it wouldn't really matter. It would only really hit 162. So what we're going to use TDC for is kind of bringing down the temps a little bit on long multi-core things. And then PPT is package power tracking. That is the total wattage your socket can use. Not super important in my opinion. You can leave that real high and just let it use as much wattage as you want. It could be useful if you have a real specific wattage limit you need for your CPU. If you're constrained by your power supply or something. Then there's a curve optimizer. The curve optimizer is the new thing in PBO2. It's for Ryzen 5000 only. It's very powerful. It basically allows you to modify the voltage frequency curve of each core in your CPU. We're going to talk about that more next. Boost override or auto OC, it just allows you to increase the max frequency limit on your CPU. Most of the time, this will only really affect single core stuff, but potentially can increase your multi-core if you have a good curve. And then there's scalar, all right? Scalar, I did a lot of testing on. I couldn't find it doing much at all right? So what AMD says it does is more aggressively pursue higher voltages. I leave it on auto or 1x because it made no difference on my system. All right, let's talk about the curve optimizer. The curve optimizer is the killer feature in PBO2. It was added for the Ryzen 5000 CPUs. It can only be used on the Ryzen 5000 CPUs. And what it does is it lets you take the voltage frequency curve for each core within your CPU and lets you modify it. So there's, when you go in the BIOS, and I'll show you the BIOS for this, there's, for each core, you can set an offset, all right? And you can set it to either negative or positive. You generally want to use negative, okay? And that provides a dynamic undervolt. That's what the negative specifies. And then there's a box to fill in a number, and that number can be from 0 to 30, okay? And each step, they're called 30. So, I mean, they're called steps. There's 30 steps. Each step specifies a 3 to 5 millivolt undervolt. Or you could call it a 3 to 5 millivolt offset of the voltage frequency curve, okay? So that's what the curve optimizer lets you do. And so looking at this stock curve, let's say this is your stock voltage frequency curve. This CPU at this voltage, let's say this is its max voltage, will hit this max frequency, all right? And so at this voltage here, it'll hit this frequency, all right? What a curve optimizer curve, let's say we've gone into the BIOS, we've set a negative offset in the curve optimizer, it would look something like this instead, okay? We have a voltage decrease in the curve. But as you can see, the frequencies are higher for each subsequent voltage, right? So for this voltage in stock, it would only hit this frequency. But this voltage with the curve optimizer, bam, hits this frequency. So that's the strength of the curve optimizer. And the other thing that's cool is it undervolts less at the higher frequencies, right? That's why I said each step is 3 to 5 millivolts of undervolt, because at the higher frequencies, it only undervolts about 3 millivolts per step. At the lower frequency, it undervolts about 5 millivolts per step. And the reason it does that is because you need a bit more voltage to hit these higher frequencies. That's how the curve optimizer lets you undervolt while still retaining these high boosts. So that's what AMD did. It's very neat. But the only issue with it is that because you've modified this very core fundamental part of the boost algorithm, you can introduce some instability, like each core, once you modify its curve here with the curve optimizer, it may not be stable at every voltage frequency point in this new curve. All right, so that's where the stability testing really comes in. And this is just one voltage frequency curve, right? There's one of these for each of our cores, right? So there's a VF. My handwriting's terrible, right? So I mean, for a 5800X, it's 8 of these, right? So there's a lot of stability testing to do. So you have to be patient to really find the best stable curve. All right, so that's the curve optimizer. Okay, so now we know what PBO2 is, but what settings should we prioritize? I came up with 2 stable configs on my 5800X and compared them with some benchmarks. I did one where I did the curve first, found the biggest curve that was stable, and then I added some boost override, and then a config where I did the opposite. I did the biggest boost override I could do without clock stretching, and then I found a stable curve for that, okay? As you'll see, I can do either a big boost override or a big curve on my CPU, and I think most Ryzen CPUs will be somewhat like this unless you have an amazing one. If you have an amazing one, great, you can have the best of both worlds. All right, so if you have to choose though, this comparison will be useful. I wanted to note that the stars next to the cores are my 2 best cores as listed by Ryzen Master, and those usually can only take a small undervolt compared to the other cores. And the reason for that, I believe, is those cores are already running more efficiently than the other ones. They're also used more often by the Windows scheduler, so their stability will be tested a little bit more than the other ones, which are only heavily utilized when there's more voltage available anyhow, or more current even. Okay, so let's see the comparison. All right. In Cinebench R23, the curve priority won in multi, and the boost priority won in single. Okay, that's not really surprising to me. The same thing happened in Geekbench. Curve priority won in multi, boost priority won in single. Okay. In Shadow the Tomb Raider at 1080p low, which made it 100% CPU bound, boost priority didn't change the average FPS at all. The curve priority increased it by 3%. And for the 95th percentile lows, the curve priority was also better than the boost priority. I also compared the effective clocks in Shadow the Tomb Raider just for fun to see if one seems to boost a little higher during the benchmark run, okay? So if we overlay these, we'll see that the curve priority does in fact seem to boost a little higher at those high demand parts of the run. Okay, so Civ 6, I ran the turn time benchmark on these, and I expected the boost priority to win this, but for the curve priority won. All right, so that's interesting. Time Spy. In Time Spy, this was just the CPU benchmark for Time Spy. The curve priority won here. The boost priority once again didn't do much. All right, it ran pretty much similar as stock, and perhaps this is because the Time Spy CPU test is it's a big multi-core test. All right, superposition ran identically on them. So this was at 720p, so it was pretty CPU bound, and there wasn't a big difference at all. So that was a toss-up. I then took these settings, this idea, and I applied it to my 5950X. So I only really did the curve optimization method to the 5950X. And I did a little boost override here. And I got pretty good results here, right? So Time Spy, it went up 4%. Cinebench R23 went up 14%. Cinebench 23 single went up 1%. It was already very high to begin with. 1682 is pretty good Cinebench 23 single. And Shadow the Tomb Raider FPS went up over 5.5%. So pretty great. All right, so that's why I personally like doing the curve first, the big curve, because that really, I think, improves all sorts of boost scenarios on your CPU. And then I find the boost override. If you really want single core performance though, go set that boost override as high as you can without clock stretching, right? Clock stretching is where you're not really getting any performance for that extra, the extra speed the CPU is running at, right? It's not really stable at that speed. All right, so find your highest boost in that case, and then find a curve, okay, if you really want max single core. Okay, so from here on out, we're going to talk about doing the curve first, and then your plus megahertz. Okay, now we're going to go get a starting setup for PBO 2. We're going to go to Precision Boost Overdrive in the AMD overclocking section of your BIOS and set it to advanced. And then we're going to first set some basic limits. If you have a 2CCD model, set it to motherboard limits for now. If you want to specify some manual ones, I like to start the 5800X at its default limits here, which I just set here. And then the scaler I'm going to leave auto. If you want your default limits and you don't know them, go to disable and then check in Ryzen Master, okay? Then we're going to go set 0 on the boost override, and then we're going to go to the curve. And the curve will go to all cores. We're going to go to per core, of course. Oh, it looks like I had some stuff in here. I'm going to zero these out to start over. Okay, so the reason why I like to use per core is because eventually you're going to need it, all right? All core is very optimistic. So we'll start at 5, okay? See how they're all set to negative? So that is an undervolt on each core, and we're just going to do 5 steps, all right, to begin with. All right, and then we're going to go back out, and we're going to save and run some tests, right? So some basic stability, all right? -5 should hopefully be stable on your system. Just run some tests, and then we'll go back into the BIOS, all right? And we'll go back and set -10 on these, all right? Whoops. Sometimes the typing is a little weird in my BIOS, but we'll go set 10 on all of them, all right? I like to go in steps of 5 as to begin with. And we're just going to do all the cores, all right? Eventually, we'll find a problem. You'll probably crash at some point. And if you do, you'll have to set that core back down 5, but then you can keep going on the other cores, all right? Whoops. All right, so like in this one on core 1, we had a crash, all right? And we're going to pause, and I'm going to tell you what to do and figure out how to find out which core crashed, all right? All right, so when you crash, how do you figure out what core crashed? Well, the way I like to do it is to go into the event viewer and go into your system logs and find a WEA error. And the best way to do that is create a custom view, a WEA only view. So to do that, you'd go to create custom view, select warning error. That's what WEA errors are. And then find WEA logger down here. Okay, select that. And then hit OK and name it, all right? I have one done already, and I have a few WEA errors here that I've gotten. So I have a few WEA errors, and the interesting part of the WEA error here is the API CID. The API CID is what we can use to find out which core crashed. This is basically the logical thread that crashed, all right? To find the physical core that crashed, you take the APIC ID, here's 2, divide it in half, and then round down, okay? So this would be core 1 for me, all right? And for APIC ID 6, I had a crash on core 3, okay? And to verify that that's correct, you can bring up CPU-Z, that being the APIC ID corresponds to that core. You can go to CPU-Z and make a report, okay? And save it. Let's just save it on the desktop. And then, where are you? Where'd it go? There it is, okay? And then we can find the APIC ID, APICs, right here. Bam. All right, so thread 0 and 1 are on core 0, etc. 2 and 3 are on core 1. So if for some reason your system maps them weird, you'll be able to find that using CPU-Z. Super handy. And then, bam, you know which core to back off that curve a little bit on, all right? And then we're gonna go back in the BIOS and start, you know, making the curve bigger, the undervolt bigger, until, you know, we can't make it any bigger, all right? And sometimes you won't get a WEA, and you just might have to wait for another crash to get a WEA. Or you can guess, maybe it's your best cores, right? Because the best cores generally, like I said earlier, can't take as big of an undervolt. All right, so that's what to do when you crash. Okay, so that's what to do when you crash. Let's just assume you have found your max curve. All right, so my max curve in this case is going to be like -20 on most cores. This is just a hypothetical. We are going to go back out and start setting our boost, okay? So we'll go up by 25 increments here, slow and steady. And then we're going to go test, just like we did at each curve setting. Test, test, test. Go to 50, if that works. Test, test, test until you start crashing, okay? 75, etc. Test, test, test. And if you want, you can try lowering your curve a little bit if you really want to hit that boost override setting, all right? I wouldn't cripple my curve, okay? Actually, I wouldn't go down to 15 here, you know, to get another 25 megahertz. At some point, you might hit a wall where you can't go another 25 megahertz without really nuking your curve. So I would stop at that point. I wouldn't nuke the curve. But that's the next thing you can do. If you're already at like -25, 30 on everything, it'd be okay to go down to like 25, 20 to get a little bit more, all right? So once you find your max boost, then it's time to really find the power limits. So we're gonna go back out and look at some graphs I did of the power limits here to see, you know, how they act and how you should set them, because it's almost like a personal preference at some point to figure out the power limits, all right? Okay, so now we're going to set our power limits. We're going to start with EDC because I think that has the most influence on boosts and scores. So I have my 5950X graphs here. What you're going to do is you're going to set an EDC, maybe start with your motherboard limits or whatever you had, run Cinebench 23 a couple times, take the average, take the delta temperature between ambient or your water temperature and the max temp it reached. Find your average effective clocks at the end of the run, record these as a data point. Okay, then change your EDC and record them again, and then change your EDC and find the trend. Maybe find the EDC you like, find it where it gets too hot, find where the scores drop off, okay? So for my 5950X, it looked like the higher my EDC went, the higher my effective clocks were getting, up to about 200 EDC, okay? And my scores just kept going up anyhow, all right? So even at 220, my scores kept going up. I stopped at 220 because that's where I thought my VRMs, you know, I didn't want to take it any higher, and temperatures were getting pretty hot, all right? So you can see my delta temps were going up as the EDC went up. It kind of leveled off here around the 200s. And then I made this last graph here that shows you're really getting diminishing returns as you up your EDC for temperature, okay? So this is points per temp, okay? Degree delta T, Cinebench points. So you're getting less points per degree of temperature that goes up as you increase your EDC. So really pick one. It's almost a personal preference, right? Do you want max performance? Just go for the moon. You're going to get hot, but hell, it'll be fast, all right? Do you want efficiency? Then you might lower it a bit, okay? And your boost will go down a little, but you know, it's your choice. It was a little different from my 5800X, okay? As I increased EDC, my boosts went down, okay? However, my scores, they kind of leveled off at around 120 EDC, okay? They were about the same, okay? Even though my boosts were going down. I picked 120 because it seemed like a point where my scores were high, my effective clocks were decent, And anything lower than that, it just started tanking the effective clocks. Temperatures did go down though, okay? So after you find an EDC you like, and it takes some patience to find, you go find your TDC, okay? You could just leave your TDC high. If your temps are good, where you like it, your performance is good, just like put your TDC real high and let it hit whatever it hits, okay? So for my 5950X, that was 162 here or something. 162, all right? I set it to 220 here, or 200. It only ever hit 162 amps here, all right? So my graph shows my effective clock's going up with my TDC until about 150. It kind of just levels off here. My Cinebench core did keep going up until it was uncapped, all right? The temperatures kept going up as well, all right? And once again, the points you get per temperature increase goes down, all right? So you are gaining less for every degree of temperature as you go up on TDC. So TDC's really personal preference, all right? Find out where you're hitting like a good score that you like, good boost for the temperature you're trying to hit, okay? I was trying to hit somewhere around 45-ish delta T, so I picked 140, I think, or 145 for my EDC on my TDC on my 5950X, all right? So you just have to test, record, and test again. Change, test, record, change, test, record, until you found it. And once you've found your EDC and TDC, you're pretty much done, and you're just gonna do long-term stress testing. This is basically use your computer. Do whatever you want, sometimes run a test, sometimes just forget about it and use it. Eventually you might crash. It might even take weeks, it might take a month to find that really weird, unstable, thing that happens. You could just be doing nothing, all right? And then you go back and you lower the curve. You find that APIC ID on the WEA, if the WEA exists, and you lower that core's curve or something, or lower your boost override if you want. All right, so that's it. And hopefully this helped. Hopefully you guys will all be able to find great PBO settings for your CPU.